All living things use energy, as that is what helps us go. And this is not the same energy that your Facebook aunt who sells crystals and essential oils defines. That is not energy. That is actually intuition, mood, and a whole lot of placebo effect. For that, we have psychology to help. No, in science, energy is the capacity to do work. Work requires you to overcome an opposing force. You see, we are all bombarded with forces, right, Obi-Wan?
Hello there. You see, the Force is what gives us our power. It binds us and penetrates us.
No. Get out of here. You're not helping.
I have the high ground.
Boy, people like to take science words and make them seem so dramatic. I mean, a force is just a push or a pull on an object. That's it. And since we are living things, we have the ability to overcome the forces of gravity and friction. But to do this, we need to exert energy. And to get this energy, we must constantly consume food that contains chemical bonds loaded with energy that can be used to build the fuel of our bodies. ATP! Not only that, we are spending our lives constantly battling entropy, or the continual disorder of things in the universe. And as living things, we fight entropy for a while, but performing metabolic reactions or chemical reactions in our body help to carry out biological processes that, well, keep us alive. And in this set of videos, we will explore bioenergetics, or how energy flows through living things. Time to power up and get ready to explore the very thing that makes all of us go, energy. The source of all energy on Earth is this amazing star that averages 93 million miles away. The combustion of hydrogen and helium within this thermonuclear reactor has been going on for over 4 billion years. Though it's not as strong as it once was, well, thank goodness for that, because if in fact it were any stronger, it would not make Earth the planet of life as we see it today. Eventually the sun will run out of fuel, but we have a good 5 billion years before we need to worry about that. Until then, it will provide necessary energy for the life-giving world we call Earth.
Well, let's zoom in to the surface of the planet. In most cases, the sunlight reaches ecosystems and is collected by photosynthetic organisms like plants, algae, and photosynthetic bacteria. But still, most of that original energy from sunlight is lost as heat, since sunlight goes in all directions in space. Earth only receives a tiny fraction of it. A rabbit can consume a flower and have its energy transferred to it, but the flower already utilized some of that energy given to it by the sun for growth and reproduction, so this is lost as heat. And when the rabbit dies, it decomposes. Any stored energy found in the flesh and organs will be transferred to bacteria and fungi, but the rabbit used a lot of that energy to carry out its daily activities. Essentially, all life requires energy from the sun to function. It's that the amount of available energy transferred from one level to another decreases, and this explains why there are lots of plants, fewer plant eaters, and even fewer carnivores in each ecosystem. To make up for it, carnivores have to eat more calories of food proportionally than herbivores. Herbivores use more calories than plants. Each energy transfer going up the food chain provides less original energy from sunlight, thus each organism must consume more than the previous organism on the food chain.
The sum of all chemical reactions in a living thing is called metabolism, and most people refer to digestive metabolism, which is one of many forms of metabolism that exist. And as complex as organisms are, so too are our metabolic processes. And this can range from enzyme activity, the production of proteins, use of vitamins and minerals, and the production of ATP. See? Metabolic pathways are called such as they are chemical reactions that take place in many steps to garner a final product. And one of the most important metabolic pathways to life on Earth is the production of sugar, especially glucose. Organisms use glucose to help produce adenosine triphosphate, or ATP. ATP is the currency or fuel needed to carry out metabolic processes inside of cells. But to make ATP, you need the chemical bonds held within a glucose molecule. But where does that glucose molecule come from? Well, plants, algae, and some photosynthetic bacteria utilize the following chemical equation known as photosynthesis, which requires 6 carbon dioxides, 6 water molecules in the presence of sunlight, and that'll yield 1 glucose molecule and 6 oxygens. The energy is sunlight, which helps to build the chemical bonds that hold glucose together. This is the main chemical equation for photosynthesis. And please bear in mind that photosynthesis is a metabolic pathway carried out by dozens of reactions between the beginning reactants all the way to the end products. This glucose and oxygen are then used
by the mighty mitochondrion
in eukaryotic cells and the plasma membrane of many prokaryotic cells to build ATP by building the following equation. 1 glucose and 6 oxygens will yield 6 waters and 6 carbon dioxides. This is cell respiration. ATP is made by taking the chemical bonds that form glucose and transfer them to the energy to build the bonds of ADP and phosphates to make ATP. Note that photosynthesis and cellular respiration are opposing reactions and that the reactants and products are reversed for each other. Pretty cool, huh? It's almost like it's the circle of life and it moves us all. Okay, never mind. I don't want a certain mouse to sue my over this. Photosynthesis is an example of an anabolic reaction, and that smaller molecules are used to build bigger molecules. And this requires energy, as that energy will be stored into the bonds that hold the smaller molecules together to make the bigger ones. Cellular respiration is a catabolic reaction, that a larger molecule is broken down into smaller ones, causing the chemical bonds to release energy. Now, please keep in mind that none of these chemical reactions can take place without the aid of enzymes, which is a topic we will discuss in another video. But in our next video, we will look more at the concept of energy.